Hi everyone, so this video is created to help you understand the calculation process of Anova. Okay, so let's suppose that you have those three groups. So three groups are A and B and C, whatever, and there are the scores. So there are 7 scores in each group. So we have 21 cases or 21 scores in our Anova analysis. So null hypothesis is that they are same. So mean of A and B and C are all same. The alternative hypothesis is there is at least one group is different from each other. So by setting those null and alternative hypotheses, we are checking whether those three groups are same. So in other words, those three groups are in the same population. However, null hypothesis is that, the alternative hypothesis is that one group, at least one group of those three groups or more than 2 or 3 or 4 groups, at least one group is different from each other. So checking that whether one group is different from each other or are identical. So that's the main logic of the Anova. So let's start from the total. So total is each case minus the grand mean. So in order to create those equations, generate those outcomes, we need to calculate the mean, the grand mean, the mean of all groups, and group mean of each group. So bar of the xj, j means the group, j is the group, and nj is number of cases within that group. So that is sum of the x minus of the x each case minus grand mean each case minus each group mean of the number of the cases, and then the between can be calculated in the way. But usually the total is within sum of square, so within SS plus between SS. So when we calculate the total and the within, we don't need to calculate the between. So I will do in this way. So the grand mean means the total mean. So mean of those 21 cases, all the cases. So simply equal. So you know that you need to start from equal every time. It's same at Google Sheet as well. So if you don't have Excel program in your computer, not in virtual lab, but in your computer, you'd rather use Google Sheets, but it's up to you. Okay, average. So now we are calculating the grand mean of the whole population. Or for example, so average and drag everything right and close the parenthesis. Wait a moment, but it means that we are not squaring here, right? So we are just calculating the average. So we should not square here. So that's very frequent mistake. Okay, so we can see that 40.29 is the grand mean. Sometimes some kind of the numbers are too big, like some decimal places are very small and long like that. But if we have that kind of numbers, usually we can make the two decimal places 100 decimal places. So we can do decrease the decimal places like that. So that will be very helpful. Okay, so the mean of the group A. So group A is here, and mean is among those numbers in the green color. Okay, so average. Okay, and those group only, just this group only, because that is, as you can see here, the number, the score minus the group mean. Okay, but scared later. Okay, so we are checking the group mean. Okay, right, like that. And also, again, the finding the group mean here. Okay, and average. And the third group mean here. Okay, So now we have the group means and the grand mean. So now we can calculate the total sum of the square. So this is the part of our main analysis here. So that will be equal, open your parentheses, because you need to square the difference between the each score and the grand mean. So each score right here, we can, because we are starting from here, minus what is the grand mean we found. So that is here. So 40.29 is the grand mean. And again, I told you that the square is very important here because this sum of the square, right? Sum of the square of the deviations. Okay? Then you can calculate the first line. Each score minus grand mean squared. So as you did so far, you can just drag it, right? Right? So these are the each scores on the each score minus the grand mean squared. So the total is the summing of everything here. So that is, you can make it here, but why don't we go to the analysis table first? So that will be sum, open the parentheses, and drag it all to add them up, and then close parentheses. That's it, right? Okay, so let's find the within sum of square. Within sum of square, it's each number minus group mean. It means that there are some three parts of the calculation because there are three groups. So x minus the first group mean. So because within this range, you have the group mean A, but from here, from this number, you have the group number B, and from here you have the group number C and group mean 39.43. So you need to calculate the calculation between the x1. So first number of the first group, okay, minus the group mean of the A is 49.71. Close parenthesis and square. Right. The important part is that this is part of the A group. So this calculation is just applied to the group A. If you drag it all, that's wrong because you are saying that all groups are the same. So we are limiting this calculation to group A because we are using the mean of the group A. Okay? So again, from here, open the parentheses, each group is number minus the group mean minus 31.71. Okay, and square root. Okay, drag it to here. Okay, equal. Okay, open the parentheses. This number minus C is here, 39.43. Okay, and 2. Right, so we are here. And then, okay, calculate this. So let's say the within is sum of those all numbers. Okay. Close the parentheses. Okay, we have the number. So I told you that between plus within is total. So you can simply from the total subtract the within sum of square. Then you can calculate here. So now you have the sum of squares of the between, within, and total, right? Okay, and you might be curious why I put this number instead of clicking this number. I will cover that in the next video, so in another example. So in here, make sure to put the number manually. Okay. So degrees of freedom. Degrees of freedom as a numerator or degrees of freedom between is number of groups, as say number of groups minus 1. So we have three groups, right? So equal, so we need to start the equation from equal. So there are three groups. So j minus 1 is 3 minus 1, so that is 2. Okay. There's still the df denominator and df within, that is n minus j. So we have 21 cases, right? Because maybe I can show you. So count from, okay, 21, right? So equal 21 minus the number of groups is 3, 18. And df total is n minus 1. So that is 21 minus 1, that is 20. So that's very simple. So now that's it. So we have all the numbers, right? So ms between the mean of the sum of squares between is sum of square between divided by the degrees of freedom of the denominator, or j minus 1, we already calculated in here. So j minus 1 is df between, we already calculated here. So this number divided by 2 is 570 something. Okay, and then within is here divided by n minus j is, you don't need to have total because there's just between, so the ratio between mean of the square, sum of squares between, and mean of the sum of squares within. So we don't need to have that. And the f is just the denominator, the numerator is here, and denominator is ms within. So we can find the f, our calculated f is 0.70108. We found the calculate. So this is what I calculated and found from the table. And I will let you know. So I already found that f is 3555, but I will let you know how to do that. In our website, we already have the numbers and the distribution here, but maybe you can find here. So this is the table, and this is the p-value. So now we are using alpha level as 0.05. So p is alpha level. So we are mostly using 0.05 as alpha level. And our degrees of freedom of the numerator is 2. Numerator is 2, so we can check this column 2, right? And our within, the denominator here, right? The within is 18. So we need to find 18. So number as 18 and 2 intersection between the 0.05 as alpha level. So if we go down 18 is here, right? 18 is here. 2 is our numerator, degrees of numerator, and then 0.05 is here. So we can find that 3.55 is our critical area. So now I made the critical area as 3.555. And then we can see our f value is 3.5. Our f value, our f calculated is outside of the critical area. Because if we want to reject the null hypothesis, our f characteristic, our f value should be inside. In other words, it should be bigger than 3.555 when based on our degrees of freedom. However, our f value is outside of the f critical. So it means that we cannot reject the null, and we need to say that there is no difference among those means of those three graphs. So we fail to reject the null hypothesis. So this is the flow chart of the calculation, and as you can see, answer key is already uploaded here. So you can practice again and again with on this example, and I will provide more examples because I will cover Anova this week, whole week. So you can practice again. Okay? Thank you very much, and see you in next video.